post it on your You should just like make like a whole video. Yeah, you should post it because we're gonna start a riot on ice stuff. Like as that one. Yeah, then we're gonna
Well, we don't have, that's what I'm trying to say. You are the last grade ever to take ISTEP. They are not requiring it anymore. After that, it's the SATs. It's just the SATs that you don't take those.
Wait, don't we have to take both? Or don't we still have to take ISEP and SAT?
Okay,
The only reason.
we will, no. We'll come back to that later. Let's go through these first, please. Okay, so we are just starting with sinusoidal graphs. So a sinusoidal graph or a sinusoid is a family of curves of graphs. So specifically the ones we're gonna talk about are the sine graph and the cosine graph because these are the most common that we're gonna use. We're going to build the original sine function graph and the original cosine function graph. And then we're gonna do two that are kind of variations of these two graphs. So when I talk about building a sine function graph, that just means plugging in angles. We're gonna use angles that exist on our unit circle because it makes it really, really easy. On your homework, they're gonna give you the degrees to plug in. Okay, so it's gonna make it super duper easy. I'm gonna go ahead and build the table. You should already have it in your notes. If not, you should write it. So for this, I went ahead and picked the most important angles that would help me build this graph. So I picked obviously my 0 angle. I'm gonna do these in radians. So we need to make sure that our calculator is in radian mode because otherwise we're gonna get wrong answers.
Does it say radian mode?
You should have either DRG where you can click that and change or mode.
Rad.
Or rad, that'll work too.
Does it matter if you're radian mode? We use 57.3.
You are using radian mode on your calculator.
Is it DRG? Is that what you said?
Yeah, or if you have an RAD button, you should click that.
Do we have to keep it in normal?
Normal is fine because that just means like the kind
Math
of
print or classic?
classic is what I prefer.
That's rad, bro.
You're so funny. So funny.
We're gonna make drain. I don't know what my uncle told me to call you drain. It's like an old joke.
It's because it's a group.
Yeah.
That was a wrestling for some reason.
Nope, that's definitely a group.
These old jokes, it's like, and you know what lunch is today?
Okay, so we are not going to build both the sine and the cosine because once you do one of these, it's really easy. And then we'll do one variation and that should be plenty for you to go ahead and do your homework. It's really nothing more than just plugging it into your calculator and plotting the point. So everybody in your calculator, I don't care if you have it written or not, you're gonna go ahead and plug these values in. So the first thing we're gonna do is we're gonna do sine of 0. Make sure you are in radian mode and you're gonna tell me what answer you get. 0, super easy. What about sine of pi over 6? There's literally a sine button.
Got it.
0.5.
0.5, then pi over 3.
3, you get 0.866.
And then pi over 2, 1. Jonah, what's 2 pi over 3?
Yeah, my computer just completely, my calculator.
Sine of 2 pi over 3.
Do we put like a fraction or like?
Like 2 pi divided by 3 is fine.
Click sign first though.
Yeah, definitely do that first.
0.866.
Perfect. Cassie, what's 5 pi over 6 going to be? Calculator's freaking out. Chandler, help her out.
0.5.
Just 0.5, yeah. You should just do sine of 5 pi over 6. Or 5 pi divided by 6. Jerry, what's pi going to be?
0.
Steven, what's sine of 7 pi over 6 going to be? I got it. I just didn't change the mode.
What is it, 7 pi over 6?
Yes.
Wait, I got to write down on my sheet.
Negative 1/2. What about 4 pi over 3, Maddie? 3 pi over 2 then is going to be negative 1. 5 pi over 3 is going to be negative 0.866. 11 pi over 6 is going to be negative 1/2, and 2 pi is going to be 0.
You know
So-
what I know?
The pattern, yes.
Yeah.
So once I have all of these points, all I need to do now is I need to put it on a graph. So my graph is going to have an x-axis that goes from 0 to 2 pi. So well, let's say 2 pi is right here. Halfway there is going to be pi. Pi over 2 is halfway between that. 3 pi over 2. And then we have pi over 6, pi over 3. Da 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 da.
So are we just taking all the whole numbers that we got up there?
All of these blue numbers is what we're putting on. Or are you talking about the?
Not like the stuff that you marked up.
Yes, I just marked all of these.
So is this a normal graph or is it like a special one?
No, it's a normal graph because pi is still just a number, but it's a decimal number, so I'm using it in terms of pi instead of in terms of 1, 2, 3, 4 like we normally do. It's still just a normal graph. My highest y value here was 1, my lowest was negative 1, and then I just start plotting. So at 0, my y value was 0, so that's the first point I put down. At, oh goodness.
0.
Yeah, I did not do this very well. Pi over 6, it was 1/2, so that's going to be here. At pi over 3, it was 0.866, so that's going to be here. At pi over 2, it was 1. Then it came back down. At 2 pi over 3, it was 0.866. At 5 pi over 6, which is approximately here, it was 1/2. At pi, it was 0, and we just keep repeating this process.
Is this what we're doing for our work?
Yes. I'm just going to approximate now because I'm tired of doing it already. So what happens, huh?
Can we approximate?
Well, you're gonna get as close as you possibly can if it's a decimal. That's all what we do. So what we see is this beautiful curve
Can I just draw the line and something around?
that looks like that. Of course, this curve doesn't just exist between 0 and 2 pi, it also exists
Oh, that's what.
on either side. That's a what?
String bean.
My goodness. So this is what it looks like. All we did was you took points, we plugged them into a calculator, and then we plotted them. Is that super difficult?
Where'd you get those points from? They were.
I told you what they were. Just like on your homework, it's going to give you a graph, and you're going to plug in all the points it gave you.
When it comes to doing, I just draw those lines.
No. No. Okay, so what I want to do now is I want to do a practice one.
Is that the cosine one?
We are going to do a cosine one, yes. So this was the fourth one that you drew in your notes.
I think I only drew 2 of them yesterday.
Is it inverted cosine?
Nope, not inverted cosine, it's just cosine. Okay,
So we're starting off with the cosine one?
this is the only other example because the sine ones, we've already done a sine function, so I'm doing cosine practice as well.
Okay.
So these are in your notes for you to refer back to later in case you have any questions, but I don't feel the need to do 4 different graphs if you're graphing for your homework as well. So on this one, it's a little bit different. So our first example was just sine of x, which means it was our generic sine function. This one is cosine of x minus 1. So I need to be very careful about how I'm plugging this into my calculator. Okay, so whatever angle I'm plugging in is going to go inside of the parentheses, and then the minus 1 is going to go outside. On your homework, you might have a number being multiplied into this x, which means it's going to go on the inside of the parentheses as well. If you have something added or subtracted at the end, it needs to go outside of your trig function parentheses.
Because it goes up.
Correct. So make sure you're paying very, very careful attention to how this gets plugged in. Okay? We're going to use some kind of like the same values for this one, just not quite as many because we don't need them. And we're going to plug them into our calculator as a practice. So the first one I'm going to use is 0. Then I'm going to use pi over 4. Then pi over 2. 3 pi over 4. Pi. 5 pi over 4. 3 pi over 2. 7 pi over 4. And 2 pi. So these are all the x values that I'm going to be plugging in. Again, we should be in radian mode because I'm plugging in radian angles. If we're plugging in degree angles, you can be in degree mode.
So is the red mode the one that gives you the fractions then?
The rad mode is the one where if we have a pi angle, that's what we plug in. It doesn't give you anything. And then we're just gonna practice. So let's start by plugging in 0 for cosine.
Zero is zero.
No, you don't.
-1. Hold on.
Do you get 0?
Wait.
You get 0.
You do. I just want to make sure you guys knew that. Because cosine of 0 gives you 1, and then 1 minus 1 gives you 0.
That's not.
When you're right, defend your answers.
Stop.
What is cosine of pi over 4 minus 1 going to give you?
Negative 0.29.
Negative 0.29.
3.
Pi over 2 will give you what? Negative 1. Because cosine of pi over 2 is 0, minus 1 is negative 1. What about 3 pi over 4?
Negative 1.7.
Negative 1.7. Then we're going to have negative 1 again.
Negative 2.
Negative.
Why
I
is
skipped.
negative
I skipped it.
Oh.
Come on. What are you
I
doing?
is negative 2. There you go.
Get with
Listen,
the
we
program.
always gotta help. We're here for mental health.
You are. So you plug all of those into your calculator, and those are the values you get.
Because it goes, and then it goes back.
So then we graph them. Yes, Kennedy.
Is it always like that?
There's always a pattern. You should
So,
always
like,
see it happen.
If I were to do like the first
But it's
5,
not the same.
would you be mad if I filled in the last with like opposites? Like it does
Well,
all.
You should make sure that it holds true. It's always going to hold true for radian measures. It's not always true for a whole number degree answers.
What does that mean?
Or if you're plugging in like 100 degrees, it might not correlate
So I always
in quite the
have to-
same pattern. You should always plug all of them in just to be sure. Unless you're plugging in radians like this, in which case it should work.
Okay.
Okay, so now we graph this.
So does it go up like the denominator? Because it goes 424, 424.
And Carol, the reason we got so defensive is because you told us that we always have to be right with our answers. So we thought you were playing mind games with us
On what?
on the negative ones.
I was playing mind games with you. That's why I said you have to support your answers.
Equals 2 equals 5.
Okay, so let's go ahead and plot these. When I plugged in 0, I got 0.
Did you know 9 plus 5?
When I plugged in pi over 4, I got negative 0.29, which is approximately a quarter of the way.
Slenderman's behind me, so I'm kind of distracted.
Then I got negative 1 when I plugged in pi over 2. I got negative 1.7 when I plugged in 2 pi over 3. No, 3 pi over 4, whatever. When I plugged in pi, I got negative 2.
And then you start going back up.
And then we start going back up using the same y values that I had before. This is not looking so pretty, but that's okay.
It's looking great.
And then we draw our graph. And it should look something like that. Of course, I know it continues indefinitely in both directions, so I should indicate that by putting an arrow on either side, showing that it continues on. There's another important feature that we notice from here called the period of our function. So the period is how far it goes before it starts to repeat itself. So the easiest way to find this period is to find the same point on the graph in 2 consecutive spots. So I have a peak on both of those and they're the peaks next to each other. And I take this x value minus this x value, which is 0, and it tells me the period for this function.
2 pi minus.
So this one has a period of 2 pi because 1 peak occurred at 2 pi and 1 peak occurred at 0.
Do we always have to do the higher periods?
6.
You always have to find your period. That's the only thing you have to find after you graph it on the homework.
So,
Why did I know?
So if I had a function, just for example, I'll leave that up, that looked like this in a second. Hold on. My period would be the x value here minus the x value there. So this is 1 period.
So you're trying to find the peaks.
You're trying to find the amount of time it takes for the pattern to repeat itself. And so the easiest way is to find the 2 peaks that are next to each other and figure out the x distance between them.
So we can't do the other one?
Which other
Going
ones?
through the line.
You could have done it anywhere. You could have done the valleys if you wanted to, but they have to be the same point
Okay.
on that shape, that
So
part of the
there's
graph.
multiple periods.
No, there's one period, but there's multiple points you could test it at to find it. But the peaks are usually the easiest. Okay? Homework's on Canvas. Actually, I might have,
I don't think you.
I printed, no, this is just quadratics, just kidding.
Yeah, we can do that instead.
No,
I'd rather
homework's
do that.
on Canvas. I do have graph
Okay.
paper up here, you're more than welcome to use. I might not have, dang it.
Sweet. No homework?
No, there's homework.
You have to wait a couple minutes before we start.
No, you should just be able to refresh it once I publish.